Hello everyone, I'm here today to tell you a little story. I assume you're here at this conference because you want to learn something, and we will get to that. But I really like to tell stories, so let's start with a little story about how I went camping one day. It was last year, and there weren't so many opportunities for travel. Hotels were closed, the rules were changing all the time, so planning a vacation was no fun. But a friend and former colleague of mine drove to a small lake about 2 hours away from Berlin, where we were able to use another friend's camper van that was parked there on a campground. We arrived there on a beautiful Sunday morning after a very relaxed road trips through Brandenburg's tree-lined roads. We found the campsite and we were really happy to see that our spot was just a few meters away from a very small lake. So we were super excited, we wanted to go swimming, but first we needed to take care of groceries. Because we were also planning to have a nice little dinner later, that's why we brought some fresh food. And that shouldn't be a problem, because inside the camper there was supposed to be a fridge. It might be worth noting at this point that I haven't been camping in a long time. I think the only time before that I've ever stayed in something like a caravan or a camper was when I was a small child. So at that time, obviously, I let my parents handle everything. So it's very fair to say that my experience with camping and how campsites work was very limited. But I mean, how hard can it be, right? So we opened the caravan and the first thing we find is a long red power cord. So that's straightforward, right? So we take it and plug it in outside in an outlet because it was right at the corner of our camping spot. Well, then the trouble started a bit because we couldn't really find where to plug in the other end. We assumed that it had to be somewhere in the camper, but where those things are usually located, we had no idea. So it took us a bit of searching, but then we found it at the back of the camper in between a lot of stinging nettles. But well, we got that done and excitedly we went inside, opened the fridge, but it stayed dark. So we pushed all the buttons we could find, we tried everything in the camper, and quickly we became pretty sure that we had a problem. There was no power. So there was also no way to store our food safely and to keep our beverages cold. So what was going on? And could we fix it? And luckily, we were very well equipped to debug this problem. You might wonder why I felt that way, because I just told you that I've not much experience with camping or anything. Which is true and fair to say, but I know a little bit about debugging, because I've been a professional software developer for more than 5 years now. So I've worked with lots of different languages, I've worked at different ends of the stack, I have been an IT consultant, I have been a full stack developer, and 50% of the dev team at a small startup. So I was very lucky to have worked on very different projects with a lot of very great colleagues and a lot of buggy software. And I don't say that to talk badly about my former colleagues and their work. That's not at all my intention, because I say that with the full awareness that a lot of times it was myself who had introduced some of those bugs. But I think this is just the reality of software development. It's just how it is, right? Either you or someone else was maybe short on time and had to work fast, and that usually means that you break something. or it means that someone who wrote the code didn't have all the information needed to build something the correct way. Whatever the reasons are, I think from my experience that almost all software has bugs. And definitely all the software that I have worked with had bugs. And very often it was on me to find and fix those bugs. So I kind of like debugging, and I have done it quite a few times. And I have noticed there's a rough process that I follow when I'm debugging. And at least that's usually what I follow if the bug is somewhat more complicated. And there are several different steps that I go through when I'm debugging something. And what I feel is that these steps and this process can be applied to things beyond software. So this is why I would like to show you the process with the example of the story of the camper van. Let's have a look at how the process looks first. So there are 5 mind steps. So the first thing that I usually need to do is reproduce the problem. If you're really lucky, the person who reported the bug already gave you that, like a detailed step-by-step guide for how to reproduce this issue. If not, then it's on you to figure it out. This step is sometimes optional. It's not ideal to skip it, but sometimes you just can't do it if it's a production issue and you can just not get correct test data to reproduce it. Then you have to skip the step. What you usually need is the second step, which is understanding the problem. So you need to answer the question, what exactly is the incorrect behavior in our code that causes the bug that we're observing? This is much easier if you were successful in step 1, I have to say. But of course there are other ways to approach it. Like you could find it by just reading the code, checking logs, or just thinking about the problem really, really hard. Step 3 is the one that your users might find the most crucial, and that is actually fixing the bug. So you change the code that produces this incorrect behavior, and then it behaves the way everyone expects it to behave. And step 4 is a bit of an extension to step 3. And it's much easier if you were successful in step 1, because then you can easily show that now with your fix, you can no longer reproduce it. So this step is just any way we can use to verify that we really fixed the bug. The final one is one that maybe should be more important to your users, because it can happen easily that you bring a bug back. Could be a bad merge request or some refactoring going wrong. And I think the best way to prevent it coming back is creating an automated test that covers exactly the code you changed to fix the bug. All right, this is the process. So let's have a look at how this works with our camper van. I forgot to mention, ideally, you write your test first. So if you, in step 1, when you reproduce the bug, already write an automated test case, you can use that for all the next steps. And most importantly, you already have step 5 covered. I like to do it that way. I admit, honestly, that I don't always do it that way, because sometimes you just get a little over eager in figuring out what the problem is. So it's still good writing the tests in the end. The important thing is to actually write them. So, and here's another little adjustment, because in reality, these steps are not always the same size. So some steps take usually much more effort. I mean, this depends totally on the bug. For some, reproducing it is the hardest, but usually step 2, like understanding the problem, takes the most time. All right, Now let's get back to the camper and see how these 5 steps would look in practice. So, we want to debug our camper problem. Remember, we don't have power in the camper, despite everything being plugged in, and we don't know why. So, step 1, we need to reliably reproduce the problem. In this case, we're really lucky because the power was just consistently off. Every time we open the fridge or try to turn on the light, nothing happens. So this is great. And it could be kind of a reason to get a bit stressed or get in a bad mood, but we were determined to enjoy this weekend and have fun. So first thing we did was keep a positive attitude. All right, so first thing is checked off. We can reproduce it. Then comes step 2, the big and intimidating large step of trying to understand what's going on. So what can we do? So we start by, okay, what do we know already? We know that there's no power arriving in the fridge. We know that we have a cable plugged in, and there's a switch that we think is turned on that was right next to the outlet. So what could be some theories? There could be a power outage on the whole campground. It could also be that there's power coming to the fridge, but the fridge is broken. Maybe the switch is actually in the wrong position, or there's another switch. Or maybe we have to get someone to turn the power on for us, for our little campsite. So we had a few theories and ideas, so we went about to test a few of them. So to test the theories, we need some way to get feedback, and ideally something that gives us immediate, fast feedback. In our case, that was something we needed to plug in into the different power sockets to see where the power is still there and where it's not. Luckily, we had some very fancy dinner plans and brought some fairy lights. So we could use those to plug them in different places to see and get some visibility. Okay, so to test our theories, we start by the quickest ones, because some would be very time consuming. We could walk all the way back to the entrance of the campground to ask there, and others would be almost impossible for us to figure out. For example, how could we check with no tools and no knowledge about fridges if the fridge is broken? So we test the things we can easily figure out. For example, is the main switch on or off? So we tried with the fairy lights, we plugged them in and they turn on. So we already have a few theories covered, right? So there is power coming to our campground. The switch is on. So that's great. And luckily we choose this route, so we didn't have to walk all the way back. All right. Now that we have excluded already some theories, we try to narrow down the problem even more. We have now a good state, that is the outlet, and a bad state, that's the fridge. So at the outlet we know there's power, at the fridge we can see that's not working. So we look for ways that we can check in between to narrow down the size of our problem. So we look for something we can test. Luckily, there's another power outlet on the side of the camper. We plug the lights in and they stay off. So, what does it mean? We don't know if the fridge is broken, but maybe not, because now it looks like the whole camper doesn't have power. Which is good, maybe, because now we can check between the camper and the outlet. This is what we do. So we follow the same strategy and look for anything we can test in between. So we look at the whole extension cord. We check if all the ends are plugged in correctly. And then we also decide to double check there was a waterproof capsule where 2 power cords were actually connected. And what can I say? When we open the capsule, it turns out, as you can see on this picture, that the 2 extension cords were not properly plugged in together. We found the bug. As it's very often the case, the actual reason for your bug is pretty underwhelming. The advantage is, on the other side, that the fix is also very easy. And I feel from my experience that this is true for many bugs. You look for a long time and then the fix is a 1-line code change. Or in our case, we plug the 2 cords together and the lights in the fridge turn on. So we can start loading the fridge with our groceries, we can keep our drinks cool, and then enjoy our afternoon at the lake, and later on make a very nice dinner on the gas cooker. The trip is saved, and that is the end of the story of debugging the camper van, but not the end of the talk, because now I want to take a little step back and see if there's anything else that we can take away from the story, because most of what we looked at now was related to step 2 of the debugging process, understanding the problem. And I feel this is not uncommon, because as I already said, this step is usually the one that's the most complex and takes the most amount of your time. And unfortunately, in most cases, it is required to do it. Because there might be cases where you can fix something without understanding it, but then you have to get really lucky. So it's the biggest step, it takes a lot of time, and that's why I broke it down a little more in in a little sub-process. I think the best way to describe it for me is as a little cycle that I go through when I'm trying to understand a problem. A lot of those steps obviously depend on the situation, and not all are always applicable. But in general, I start with collecting everything I know, then thinking about possible reasons why it's broken, like coming up with different theories. Then I try to find ways to test those theories. And if I'm running out of theories that can be easily tested, I try to just narrow down the scope of the problem until I either understand the problem, come up with new theories, or find other clues. So basically repeating these things until something works, and at some point you know what's going on. You might remember a few of these steps, right? Because that's exactly what I did in the camper van example. But I want to also show you how those would look like if you're not debugging your vacation, but code. So collecting clues, how would that look like? First thing we can look at is the bug report that was maybe written by someone else, but might already contain a lot of useful information. For example, what type of user was affected, what product is affected, what areas of our software are connected to this observed behavior. And a very great first step, I think you all know that, but it's always to look for errors and then to very carefully read the error message. I assume you're all smart and you already do that, but I just wanted to mention it because I have met people in my life that ignored this valuable source of information, and I cannot recommend that. Where would you find the error message? Well, if you can reproduce the error in your local environment, that is great, because then you might usually find it somewhere in your browser window or in some in your console as output from your application. It could also be when you inspect the network connections that it's popping up there as a response. If you cannot reproduce the bug, then it's a bit more ugly. Then I hope for you that you have a good way to access your application logs, for example, on the server, or even better if you have a tool like Kibana or Datadog that helps you with log processing and allows you to search your logs very comfortably, so you can more easily trace down an error log that fits the time frame when you observe the bug to happen. So in many cases, the error message will also be accompanied by more helpful information. For example, if you're lucky, you will also find the stack trace. And even though it's very long and very red in many cases, you can find some very useful information, and that is the file, the method, and the line where the problem created the error, which makes it much easier then to start looking there for more clues. All right, next thing is be like Sherlock Holmes and think about all the clues you found. And then try to come up with one or more theories that would explain the unexpected behavior you're seeing. I would say that having more experience as a software developer and having seen more bugs helps when you try to come up with theories. Sometimes you will already have like a gut feeling about what's wrong because you've seen something like that before. Sometimes it's totally mysterious, but then always look out for unexpected dependency updates. That's always a good candidate for things like that. And if you cannot come up with any theories, don't worry. Sometimes you just need more time to look for clues and narrow it down. Yeah, I already mentioned the dependency updates, so just to stress this point even further, this is always something to keep an eye out for, because it happens so many times that even though it's a patch version, so nothing is supposed to change in a breaking way, it can happen. So I always recommend that you know when dependency updates happen and not have them automated in some way. The next big step is testing our theories. When you have one or more theories in mind, it's time to look for ways to test them, to either prove that they are true or to disprove them. And I usually try to start with the ones that are the easiest to test or the ones that seem very likely. How we test them can vary a lot. So I usually try to come up with a manual or automated test that would prove or disprove them. And usually I try something that I can do quickly and most importantly without making anything worse. The options are kind of endless, so it's a bit hard to give you more details here. But in general, if you can run the code locally, you can do anything with it that helps you. You can remove parts of it temporarily, you can change it, you can send manual requests if the problem is somewhere in an API, and then you can have a better look at the result without having to run the whole application. And what you need for testing is visibility into your application and fast feedback cycles. The faster you can test your theories, the better. And what we need is some way to look into our application. So for our camper van, if you remember, we had some lights to show us if we had power or not. In code, it's a bit less literal, and visibility can include things like application logs, automated tests, the debugger that helps us to see the values that different variables have, and some of these you either need to set up earlier, like logs, but some of them you can add on the fly while you're debugging. For example, temporary print statements or breakpoints for your debugger. Little tip, know your tools. For example, conditional breakpoints are awesome. Imagine you want to debug a certain condition that happens somewhere in a loop, but not on the first iteration, but maybe on the 20th. And then you have to step through all these breakpoints to find the one that's interesting. In this case, conditional breakpoints are awesome. So it makes it much more convenient to only look at the interesting cases. So in the example here on the slide, you see that you can set the breakpoint in code with the debugger statement, or also in the browser tools. And you can then execute it inside of an if statement. And this is just one example. What I want to highlight with that is that it's really useful to look at what your debugging tools and your environment provides you to help you gain more information. Testing theory is not always the end already. It's a step. And sometimes you cannot fully prove a theory. Or maybe you have some theories that have been disproven, and you might run out of ideas what to try next. So you might start at some point to get a bit annoyed by this bug, or you question your life choices of becoming a programmer, but don't despair. There's always one more thing you can do, and that is narrowing down the scope of your problem. Remember how we did it with the camper van, where we found a good and a bad state and then try to find another thing in between that you can test? This usually also works with code. One example would be if you have a microservice architecture and you know that something is wrong, and then you try to narrow it down where exactly in this service-to-service communication something goes wrong. So that at some point you narrow it down to only one service that you can then debug more easily by running it locally and using debuggers, for example. And the most important thing in all of this is keep going. You repeat the steps until there's no more progress. Ideally, that is because you found the problem, you understand why the bug is happening. But sometimes you're not making progress anymore because you're burned out a bit. And then you need to take a break. Step away from the problem for a bit, or ask for help. This is very important. The someone you ask for help could be the internet. So Googling some error message that you're getting is always a good starting point to get some new ideas. And even if it doesn't tell you directly what's going on, it might also give you some more clues for directions that you could look at. Another thing that you could look at is documentation for the libraries you're using. So let's say you were already able to follow your bug through the stack trace to a specific part of the code where a third-party library is used. And sometimes it can be helpful to double-check the documentation to make sure that everything that you do with this library is correct. Maybe, for example, looking at issues in the GitHub repository of that library. Or maybe there was a recent update that introduced the problem. And if you're lucky, it's already fixed. One thing that I always recommend is if you want to ask, to prepare to ask for help later, is to make notes while you're debugging, so that when you go to a colleague or someone else to ask for some help, you can give them like a short summary of what you've already tried, what you've already proven, and what you could already rule out as the cause. In the overall process, at this point, we would be still at step 2. And if you figure it out, I promise you, at some point you will figure it out, then you will have the gratifying feeling that you've done it. And the motivation you gain from that will give you the energy to power through the next step and to fix the bug. And usually this is a bit underwhelming because it takes very little time, usually. If you've already understood the problem, you've done most of the work already. Often what's left is a tiny code change, like with the caravan, where the fix was just to plug in a cable. So very often that hard work that we did in step 1 and 2 especially results in a one-line code change that corrects a typo or checks for a null object or whatever. Pretty underwhelming. But if you were paying attention, this is not entirely true. Your PR should not only contain this one line that fixes the problem, but also a test that you wrote to prevent it from coming back. And then it should also be very easy to verify that you've really fixed it. But sometimes you might have someone else who needs to also check your fix until you can finally be done with the bug. So we now walk through a whole debugging process with the example from the real world, the camper van. And I want to be transparent here. This process is more like guidelines. It's not very strict. Sometimes I do the things in any order. Sometimes I start with a fix because I think I'm very smart and I know what the problem is. Most of the time I'm wrong, and then it turns out I'm not that smart and I have to start back from the beginning. But the most important thing is that this process gives me some framework that I can go back to if I'm feeling lost. So this helps me to stay calm and tackle debugging like a puzzle or a challenge, and not become annoyed or desperate. And I know this can be hard, especially if the bug causes a production incident and everything is super stressful and has to be fixed immediately. But I think in general the process helps you, and maybe you can also find debugging a little bit enjoyable. I hope you can take that away, and I also hope the process will help you sometime when you're stuck because you're faced with a very, very nasty bug that you can just not figure out. Because I'm sure you will figure it out eventually. Thank you so much for your attention. I wish you a great rest of the day. Enjoy the conference, and I'm happy to answer more questions.